Hello, ladies and gentlemen. This is the lesson that we were supposed to do today, so February 18th, Thursday. We are going to work on multiplication, property of equality with fractions. Now, the expectation is that you watch this video, take some notes on the video, and then continue on with the ALEKS assignment, being that you'll have the background information to do the assignment that was due today. Excuse me. So what I want to do here to start is just share my screen, and I'll take you through kind of what the week looks like. Obviously, we're off Monday. Tuesday, we did word problems. Yesterday, we caught up. And today, like I said, we're working on multiplication property of equality with fractions. We should have the background in order to do that ALEKS assignment. And then we'll pick up tomorrow with the same thing, except instead of dealing with fractions, we'll deal with whole numbers. Okay. So just as usual, I'm going to pull up my camera here and we're going to walk through what the multiplication property of equality means with fractions. All right. And one thing that we want to keep in mind, something that may or may not be new to some of us, is this idea of a reciprocal. Okay. And the reciprocal is if we were to take a fraction or even a whole number. All right. So actually, we'll start with a whole number, such as 2. Well, 2 is the same thing. We can look at this as 2 over 1, right? Anything divided by 1 is just itself. So you can take any whole number and write it as that number over 1. Well, the reciprocal of 2 over 1 would then be the opposite of that fraction. So we take the fraction and we flip it, okay? And this here is what's called my reciprocal of that whole number. Okay. And what we can do is take a look at any reciprocal of any whole number or fraction, because it's going to eventually help us when we start to multiply. So as an example here, if we wanted to take a look at these numbers, such as 1/3, 3/4, and let's say 5 over 2, right? These are all perfectly normal fractions, things that we might have seen before in a class. We want to write the reciprocal of each. Well, the reciprocal of each, and I'm just going to label that as R. For the first one, we'll take that 1/3 and flip it. Well, the reciprocal would then be 3 over 1, or just 3. If we take the reciprocal of 3/4, we just take that fraction and flip it. The reciprocal is 4/3. And then the same thing in the last example here. I take my fraction 5/2, I flip it, and I have 2 over 5. Okay, so that's what the reciprocal is, just a matter of flipping whatever the fraction or whole number is. And the reason that we're going to use this, so the big idea behind why we want to introduce reciprocals here, is because if we were to take a number, right, that number such as 1/3, and multiply it by its reciprocal, in every single one of these examples, when we multiply them together, we're going to get 1, right? Because notice, if I just take a look at that last pair of fractions there, if I do 5/2 times 2/5, notice that I have a 5 in my numerator here and in my denominator here, 2 in the numerator here, 2 in the denominator there. Well, what's unique about this when I multiply them is I can do what's called cross simplifying, and all of these just become 1 based off of my simplifying, so I just have 1 left over. So one thing that you want to note is that any number times its reciprocal is going to leave you with 1. Okay. And like I said, the reason that we're doing this is because we're going to start to look at multiplication equations with fractions where we need to solve for a missing variable. So just as maybe the first example, we have 3 over 5x is equal to 21. We want to be able to solve for x. We want to get x by itself. Well, the first thing that we want to do, and I'm going to make notes over here for the steps, is to multiply both sides. And it's important that we do it to both sides by the reciprocal. So take that fraction there that's attached to the x, and we're going to multiply both sides by the reciprocal. Well, if I'm looking at 3 over 5, the reciprocal would be 5 over 3. And I'm going to multiply that on both sides. The second step would be to then cross simplify. So notice that 5 and 5 will cancel, 3 and 3 are cancel. I'm just going to be left with an x here. I want to cross simplify over here as well. Well, like I said in the first example when we were talking about reciprocal, 21 is the same thing as 21 over 1, right? I can just make that a normal fraction. And I'm going to cross simplify. Well, the 1 and the 5, those are going to stay the same. There's nothing I can take away. But notice that 3 can become a 1 because it goes into 21 7 times. And what I'm left over with is 7 times 5, or just 35. And my answer for x, when I'm solving for x, I get that x is equal to 35. We're going to take a look at one more example. So after I cross simplify, if I can, I simplify further. And that was the step in which we multiplied 7 times 5. My next example, I have 7 over 6 x is equal to 49. 7 over 6x equals 49. First thing we want to do is multiply both sides by the reciprocal of that fraction. So I'll multiply this by 6 over 7. Again, the reason that we do that is because we're left with a 1. The 6 is cancel. The 7 is cancel. You should always be left with just that variable when you multiply by the reciprocal. Okay, that's something that you might want to note, is that you'll always be left with whatever the variable is. Whatever I do to one side, I have to do to the other, though. So I'll multiply this side by 6 over 7. And now I just cross simplify again. Well, as we said before, this could be 49 over 1. The 1 and the 6 don't simplify at all. But notice that 7 goes into 49 7 times. I'll simplify further. I have 7 over 1 times 6 over 1, or just 7 times 6. And that gives me 42 for my answer. So long as you follow these steps, you multiply both sides by the reciprocal, cross simplify, you should be left with a variable on one side and a simplified whole number on the other side. It's not always going to be the case, and we'll see that later on in class. But if you simplify further, you should be left with a number that is a whole number or an integer based off of your steps here. Okay. So just to kind of reiterate some points from earlier, if I pull up the Schoology folder as well, we have now done multiplication property of equality with fractions. That was taken care of today in this video, and you are able to do your ALEKS homework assignment.